Hello NSA student, this is Mr. Hinton with the Math Department dealing with some frequently asked questions in week 21 of the geometry course. Now, what is the value of x given that PQ is parallel to BC? So the first thing, we're given that these two lines are parallel, and we learned in this week's lesson that if you have a polygon, it's true for triangles, it's true for trapezoids, parallelograms. If it's intersected by a parallel line, then it creates a proportional relationship between the sides that are formed. So in this particular case, 8 divided by x, and we get that from these two sides here, 8 and x, is going to be equal to 12 divided by 18. And this proportional relationship is going to exist, and as always we revert back to our algebra skills. To solve a proportion, you cross multiply, and we're going to get 8 times 18 equals 144 equals x times 12, which is 12x. And then when you divide 12 by both sides, or divide both sides by 12, we get x equals 12. Okay. Now there could be some variations of this. They could ask you to what's the length of AB, for example. And another thing that you often see in this context in week 21 is are these two triangles similar? Is APQ similar to ABC? And of course the parallel lines are going to form corresponding angles that are congruent. And so those two angles are congruent, and these two angles are congruent. And so those two triangles are similar by angle-angle similarity. And that similarity of the two figures also ties into the proportionality of the lengths of the sides. There's one problem, if I could switch to a different problem, that I see quite often from this same section dealing with the same skill is this problem. And what happens here, what's different in this problem, is that you end up with a quadratic relationship. It looks a lot more complicated because of all the x values that are involved. Everything has an x. But we're going to do it the same way. X divided by x plus 5, that's the proportionality of these two sides, is going to be equal to x minus 2 over x plus 1. All right. Now the difference here is that we have to use the distributive property when we cross multiply. So x times x plus 1. I'm going to show these steps. It'll be x times x plus 1 is going to be equal to x minus 2 times x plus 5. All right. Then we distribute on the left. We get x squared plus x equals. Now when you distribute on the right here, you have to remember that you're distributing not just the x, but you're distributing the negative 2 also. So x has to be multiplied by both of these things. And then again, the negative 2 has to be multiplied by both of those things. And you may have remember this being called the FOIL method from Algebra 1. But x times x is x squared. X times 5 is 5x. Negative 2 times x is negative 2x. And negative 2 times positive 5 is negative 10. So when we get everything nice and simplified, that gives us x squared plus x equals x squared plus 5x minus 2x is 3x minus 10. And then from here we're going to solve for x. Now luckily for us in this problem, we can subtract x squared from both sides, and we don't have to deal with the any of the quadratic techniques. If the x squared didn't go away, then we would be forced to set this equal to 0 and then solve by factoring or solve by the quadratic formula. And then we're going to have, after we subtract x from both sides, we get x equals 3x minus 10. And you can subtract 3x from both sides and divide by negative 2, and you get x equals 5. So our solution here is x equals 5. So that's how you are going to solve these types of problems when you're given the parallel lines intersecting or creating two different triangles within a triangle. and it's always going to create this proportional relationship that you can solve. Thanks, and have a great day.